You're watching Code Like an Architect series with Adil Ata on ArchiWisdom. When we face a problem, we break it down into smaller problems and then solve them individually. When we design a system, we don't just build it as one large piece. Instead, we design its components separately and then bring them together to create a single entity. This is called composition. The concept of composition isn't limited to programming, but it's a universal concept. If you look around, you will notice that almost everything is made up of multiple components. Even things that appear as a single entity at first glance are often composed of several parts. It's rare to find something that's truly just one piece. Even very small things are often made up of multiple parts. Even seemingly simple objects are often composed of multiple components. The concept of composition is present in every industry, including the software industry, especially in software architecture. In fact, the very definition of software architecture revolves around components and their relationships. Thinking in components is an architectural skill. Composition is an incredibly broad and powerful concept. The good thing is that in object-oriented programming, we also have the concept of composition. But unfortunately, most of the developers do not maximize the potential of composition in their work. They don't think in components. They normally don't break down their problems into smaller components. They do follow the high-level organization that's already given, but they don't further break down their problems into smaller objects while working on a story level. Obviously, not all developers do this. The questions every developer should ask themselves are: do I break down my problems into components? Am I truly maximizing the potential of this powerful feature in my work? Do I end up writing very large classes? What am I missing? What do I need to take my work to the next level? Composition, the architect's tool. How good are you at composition? With the help of these 3 tests, you can evaluate your current skill level. At the same time, they will also help you develop and improve your skills. Test 1. You need to add notification support to your system. The system sends a notification whenever anything important happens. Notifications are always sent on 3 platforms: SMS, email, WhatsApp. How will you implement this? We will need 3 major components: SMS notification sender, email notification sender, and WhatsApp notification sender. In addition, we have a notification service which is composed of these 3 components. In addition to these components, we will also need some additional underlying components to make it work. Test 2. Implement the functionality of initial email response. We often receive emails from customers. To manage them effectively, we need to implement an initial email response functionality. As per the requirements, whenever a new email is received, we will parse the email, create a summary, extract the call to action, extract any event information from the email, and schedule the events on the calendar. Extract tasks and create them. We will assign those tasks. If the user's subscription is premium, we will assign those tasks immediately. Otherwise, we will assign them later. If the subscription is standard, we will use the priority scheduling algorithm. Otherwise, we will use the normal scheduling algorithm. Upon assignment, the system sends a notification to the assignee. Finally, we will create an email ticket with all the information added. And then we will send an acknowledgement reply to the customer. Let's try to think in components. First of all, let's try to identify the individual components from these requirements. What components do you see? a summary maker, call to action extractor, events extractor, events scheduler, task extractor, task creator, task assigner, a component to access user data from database, and similarly, data access components for task and events, a priority task scheduler, a normal task scheduler, a scheduling system, a notification system, email ticket creator, an email replier. These are the components that we need. It's not necessary to follow a strict one-to-one component-to-class mapping. Depending on our needs, we can combine multiple components into a single class. Similarly, we can further break down some components into multiple classes. This is how our components look. Here we have some parsers and extractors. Here we have some classes related to events functionality. Event DB service for data access. Calendar service which books events on calendar. And event scheduler service which uses these two classes to schedule an event. Here we have some classes related to task functionality. Task DB service, user DB service, task assigner which is used to assign the task immediately. Priority task scheduler and normal task scheduler which are used to assign the task later. We also need a scheduling system for assigning later. For that, we have a scheduler service component. We have a task assignment job handler, which is called when task assignment job is triggered. Once the task is assigned, the task assigner sends a notification. Then we have the email ticket creator class, which creates the email ticket with all the information. And then we have this email replier class, which sends an acknowledgement reply to the customer. Finally, we have an email initial response service, which ultimately uses all these components. This class is composed of summary maker, call to action extractor, events extractor, task extractor, event scheduler, task creator, email ticket creator, and email replier. Then all these classes are further composed of their subcomponents. Let's code. Test 3. Our company is starting a new project. We need to develop a